Ron Busciolano. Sorry. He is a supervisory hydrologist with the U.S. Geological Services New York Water Science Center and is currently supervisor of the Hydraulic Surveillance and Analysis Section for the Farm Program Office. Ron began working for the USGS in 1985 and currently oversees the operation and administration of a multidisciplinary data collection program that encompasses a network of approximately 500 groundwater and surface water stations. This network is the primary source of hydraulic data for the region, which includes Long Island and the 5 boroughs of New York City, one of the most
water levels are in the lower percentile, so they're either much below normal or near record lows. And this is primarily attributed to the lack of precip that we've had over the past few years, which I'm going to go into a little bit more. We had a lot of rain the last week. We had a little recovery. We're not sure where that's all going to end up. Continue to get more rainfall, and we'll start seeing increases in water levels. But if we look at the past couple of years, this is the Para Hydrologic Drought Index. We could see current conditions in the last couple of years have been well below normal as far as overall precip. And this index is showing that by the bars going down below this midline here. It's the longest period of low levels since the 1960s drought. And that's the 60s drought there. And that was the all-time low levels for most of the wells on Long Island, and it's sort of the benchmark that we go by when we look at low groundwater levels and low stream flow on Long Island. So you can see we have been pretty low, and that is the reason why we're seeing a lot of these declines. Looking a little closer at the precip data, we could see that in 2015, these dark reds here show precip about 20 to 25 inches below normal in some areas. Again, in 2016, we see the same thing. So we had 2 big years of low precip. And now we're getting into a little more wet period, but it's still been below normal. But a lot of the rainfall has been falling during periods of the growing season. So a lot of it hasn't been able to recharge the aquifer. It's been taken up by the plants and transpired back into the atmosphere. And also, it was used to replenish the soil moisture deficits that have built up over the past couple of years. So what does this mean? Well, it means that our groundwater levels are declining and our stream flow is declining. This is a trace, the black line is a trace of our Carmen's River gauge at Carmen's River. This gauge has a record of about 75 years. And you can see when we get into these brown levels and these orange levels, these again are the lower percentiles. This means that we're getting really low stream flow at these locations. And actually in 2016, we hit record lows. This last point over here was before this big rainfall that we had over the weekend, but it was after the rainfall that we had the prior week. So we're still pretty low. We expect to see an increase and then potentially a decrease again. But we'll see where this goes with the fall precip season that we have coming up now. Another thing here, lake levels. Lake levels are in contact with the groundwater system. So we're looking at 2 lakes here. This is Lake Ronkonkoma. This is Lake Panamoka. These photos were taken this past weekend. We actually went out and did a drought synoptic at a number of wells and a number of lake levels across Long Island. So you can see these red arrows are pointing to get where normal levels for the lake would be. They're very low. Hopefully, did the Lake Ronkonkoma come up since then? Do you know since?
No, it hasn't been any. Actually, it appears that it's still decreasing.
Still decreasing. So we still have a problem, and hopefully there will be a little rebound as the water moves into these lakes. But we're not sure yet what we're going to see once we get out of this next week or two. So why do we measure stream flow and lake levels? Well, lakes and streams are a window to the water table. They are primarily groundwater fed on Long Island, and they're the first to show trouble in the aquifer system. So it's very important that we monitor these streams and lakes to see what's going on below. Small changes in the water table can produce larger changes in streams. Reduction in stream reach, reduction in stream flow, lowering of lakes. And human-induced stresses like pumping and sewering can really compound these effects. And we've had, effects of pumping and sewering over time in Nassau County. Some streams have to be replenished with water pumped from the groundwater system into the streams. So we have seen these problems before, and we are seeing them in other areas as well. So when you look at these stresses, sewering removes water from the aquifer system, like we were talking about. It actually takes it out of the system, and you can reduce the water table. Reducing the water table reduces stream flow and lake levels. Pumping can create local or regional declines that can induce saltwater intrusion. And we have seen saltwater intrusion occur in many parts of Long Island. If you look at a trend of pumpage for the whole island, this here actually is broken up by aquifer. The blue is the water table aquifer, the red is the Magothy aquifer, and the green is the Lloyd aquifer. But from pre-development to about 1985, there was a general increase in overall pumpage across Long Island. Since then, 1986 to 2003, we see a general leveling off of pumpage, but the pumpage centers have sort of moved east. They've turned pumps off in the city, and they've slowly moved east into Suffolk County, so we have to watch for concerns further east now than we did in the past. So when we talk about saltwater intrusion due to pumping and sewering and some other aspects of human and natural stresses, there are some areas of major concern and some areas that we already know that there is intrusion going on. Great Neck Peninsula, due to overpumping in those areas. Manhasset Neck Peninsula, Bayport. We believe there is some intrusion now in the Lloyd Aquifer in the Long Beach area. And long-term intrusion, which I'll show a better map for in a minute, in southwest Nassau County, where pumping on the mainland has been pulling salt water inland for a number of years. And the USGS monitors this intrusion over time by doing borehole geophysical logs of different wells that we have as outpost wells. And we take that data and produce reports to show how things have changed over time. So when we have all these stresses into the system, we need to develop ways to monitor it and determine how it's going to affect sustainability in the past. And one of the things that the USGS is working with now is this new sustainability of the Long Island Aquifer System program. It's a project that's being funded by the DEC, and what it is it's a project to look at sustainability of the groundwater resources. So the objectives are to improve the current understanding of regional hydrologic framework, including the position and movement of the freshwater saltwater interface, which is very important in many areas of Long Island. Develop a new groundwater flow model of the Long Island Aquifer System. And this flow model then can be used to conduct a comprehensive assessment of groundwater sustainability under changing stress conditions. So we'll be able to plug in multiple scenarios, looking at, if you put a supply well here, what will that do to movement of groundwater? What will that do to potentially movement of saltwater intrusion in areas where there is intrusion concerns? So where are we now in this program? So we had just started last year. We actually pulled together a lot of information from from water authorities, from other agencies, and made a database of all the information for all the wells that are available, the pumpage, and all the other data that we need to incorporate into the model. Now we're actually starting the field work. So what we're doing now is starting to look at areas to do surface geophysics, which are these black dots here. And this map just showing the extent of that saltwater intrusion in Nassau County that I told you about in the Magothy Aquifer. So we're going to go along, and at these black dots, we're going to be putting current into the ground and measuring down into the subsurface about 1,000 feet down so we can actually see where there might be saltwater intrusion. And this is going to help us guide the well drilling that's going to come next. And the well drilling is very expensive, so we want to know where to put these wells before we actually start the drilling. So this is one way that we're using new technology to look at different aspects of where intrusion might be occurring at this time. Phase 1 of the drilling will be starting later this year, probably in the spring. And these are the wells we're looking at to install for phase 1. It's going to be towards the western part of Long Island. Then phase 2 will work towards the east end. And phase 3, if there will be funding for that, will actually fill in any gaps. And what we're going to do is we're going to take all this information that we're collecting from these wells. We're going to take geological log cores. We're going to collect geophysical logs. And we're going to incorporate that into a new framework for Long Island. And then incorporate that framework into the groundwater flow model. And finally, right now, we are in the development stage of a 24-layer model for all of Long Island. And we're taking other programs, leveraging other programs, modeling programs, and other data programs to incorporate into this model and develop a really robust model. The framework should be ready by the end of this calendar year. And then that's the point at which we start testing, calibrating, and incorporating the new well data as we collect, or as we install new wells across Long Island. And finally, we have a website up for the sustainability project. As we move ahead and do more research and get results out there, we will post all that onto the news section of this website. And I want to just close with one comment, or 1 or 2 comments here. I've been with the USGS for over 30 years, and I've noticed these past few years there's been unprecedented coordination efforts between different agencies. And it's been great. We've been working with many, many different agencies, LINAP, New York State, DC, state, county, towns, NGOs, universities, water suppliers, and not only for the sustainability work, but for other ongoing projects. And I think this is the reason why a lot of things are moving forward now. People are talking, working together, not duplicating effort, and getting things done. So I think it's a good thing that we have going now, and hopefully that this continues into the future. So, and that's all I really have. So I think we'll have time for questions later, right?
Yes. Yep.